Okay, we're on. Okay, friends, so today we'll talk about two topics. Okay, topic number one is how do you go about creating ERD models? Okay, what are the typical steps that you go through to create an ERD model? And topic number two, which is a part of that first topic, is normalizing data, because the last step in creating a data model, an ERD model, is normalizing it. Okay, so we'll spend quite a bit of time talking about normalization. Okay. Now, when it comes to the first topic, how do you go about creating an ERD model? In a way, there is not much to say here. I mean, it is a complex topic, but there's not much to say here because it's something that is a creative process, right? I mean, you cannot just create some kind of algorithm that will go ahead and create a good ERD model, okay? This is something where you need human creativity, right? Human intelligence, human judgment. There's no one single way of creating an ERD model. A lot of experts may disagree, whether your model is good or bad, right? So that's why there's not much to talk about. I mean, how do you explain to somebody, how to write a book or how to write a good song, right? I mean, I think the only explanation I can give, if you want to write a good book, you need to start writing a book. You need to sit down and keep writing a book until it becomes good. I mean, that's the only thing that can be said, right? Okay, so I will use a small example for this lecture, and this example will come from your assignment 3. Okay, so here I posted the case itself. It's also in your textbook. You don't have to read it from your textbook. I'll put it on the screen right here. I'm not gonna go through the entire case because it's your job. But what I will do, I will concentrate on point number 3. I think last time we discussed point number 1 and point number 2, how to get started with those, and now I'll concentrate on point number 3. Okay. So take a second, please. Take a second, please, to read point number 3, right? And if you're watching this presentation integrity, just like pause your presentation for a minute just to read that point number 3, and I'll pause recording. Okay, here. Okay, so I'll resume my presentation. After reading this point 3, hopefully you have a few ideas, right? A few ideas about entities, meaning the things that you need to store data about. Okay. By the way, what we are doing right now approximates something called a JRP session or entity discovery, right? So the first question, that you need to have when it comes to creating an ERD model is like, where do those entities come from in general, right? Well, they come from research, right? And research can take any forms. One form of doing research, you can read some secondary sources. Like that's what we did right now, right? We read this document that talks about requirements towards a library, right? Or library information system. However, you understand that those requirements, this case was written up not like based on somebody's imagination, right? It was probably based on some form of JRP session. Now, JRP stands for Joint Requirements Planning. So maybe whoever wrote this case, they got together with library personnel and they started asking, so what do you do, in the library? What is your role? What kind of things, you're storing information about, right? So he kept, the system analyst kept asking those questions, and based on those questions, the following case was described. So basically, somebody was taking notes, right? And he created like this kind of, maybe later on he or she typed his notes, maybe voice notes or handwritten notes, into this kind of form, right? Saying, this is what I found during this interview session about the library, okay? And now it's given to you, okay? So basically, when you have a JRP session, I'm sure there are a lot of books written on the subject, a lot of manuals how to conduct a proper JRP session, but at the minimum, just ask people what are the things that they need to store data about, okay? So that's the basic question. So let's say you work as a librarian. What do you want to store information about? Do you want to store information about books? How about library members? What about their interests, right? So ask those questions and you will get a sense of what kind of entities and attributes will be on your model, okay? Again, I told you that you can study secondary resources like existing forms, files that people already have, because they're already storing something in manual paper-based format, right? So from that, you can also deduct what kind of entities and attributes you need to have. Scan use case narratives. Use case narratives meaning like the things that people wish, scan them to identify nouns. So when I read this point number 3, I identified several important nouns. I mean, of course, you don't want to identify every noun in that passage, right? But there are some important nouns, right? So let me capture those. So one noun that I got, and then you will help me out, is that member, right? Library member is a big component of this scenario. So we need to store information about library members, right? Anything else? Any other important noun that you see there?
Interest.
Interest, right? Anything else? Book, right? So I think you're kind of on the same page with me. So when I read this passage, I identified 3 nouns: member, interest, and book. So that kind of tells me that we need to start with the following 3 entities. Okay? So let's go back to the step model. Now, the first step that you may want to do, once you identify those important nouns from a narrative that you generated as a part of some kind of JRP session or interview, you want to create a context data model. Context data model means it's simple. It includes only entities and relationships, right? So you don't worry about attributes at this point, okay? If you do it in a very granular way, it's probably a wrong approach, because you may get paralyzed. If you start thinking about every detail, every attribute, every foreign key, I mean, nobody's smart enough to wrap his or her head around the entire database, right? So don't start small. Start with a sketch, okay? Again, this is creative work, and this is how artists work. I mean, have you ever observed how people do paintings, like realistic, like kind of photography quality painting? Have you seen how they do it? I mean, they don't start with every detail, right? Instead, they start with what? With a very rough sketch. And sometimes you're amazed that they start with something like this. I don't know. I don't know what it is, but it's basically like a sketch of a horse and a person sitting on a horse, right? So that, I mean, literally, it will look something like this. So they just want to like put like on a canvas, locate those shapes. And then what's amazing, they keep adding details like nose, right? They keep adding details until they have a photography-like image of a horse, right? It's amazing to me, right? Very rough sketch, and then you add details. So you want to be like an artist, right? Don't start with details, like putting every detail. Just rough sketch, context data model, and then you start worrying about keys, about attributes, and all those things, right? So this is how a context data model will look like. Just entities, relationships, that's it. Okay? So let's start doing that, and I will use Glyphy for that. So I'll put 3 entities here. One will be member. The second will be interest. Will be both. By the way, those names may not be very good, but I'm trying to keep it short and simple. I don't like those kind of one-word names because sometimes it's easy to forget what you mean by interest, right? So maybe I'll put like reading interest, okay? And instead of member, I would put library member or something like that, right? But let's keep it short for now. Okay, now, there is something that is discussed in the case about the relationship between interest and books. Let's go back here. It says, she wants to classify each book as being in just one category of interest. Okay? Now, of course, some people may argue that one book can have many categories, right? But maybe the librarian wants to keep it simple and straightforward for members. So if somebody asks, like, for a specific, for a specific subject, like, what do you recommend when it comes to, I don't know, ancient Rome history, she can give like a very straightforward recommendation. So maybe he or she doesn't want to keep it complicated. So one book belongs to just one category, right? One interest category. Okay? Which tells you that in this diagram, book will be related to exactly one interest, right? So there will be one on this side. Now on this side, one interest can be related to how many books at the minimum? Probably like 0, many, or 1 or many, right? I think it could be 0, right? Because let's say we have a new topic, let's say big data, right? So maybe they already entered that topic, but they haven't purchased any books for the library related to big data. So it's 1 and 0 many on that side. So we'll put it here like this. So we need this kind of cardinality. Okay. What about the relationship between members and interest? So one member can be related to how many interests at the minimum? So one person can be interested in minimum in how many subjects? Minimum, it depends. I would say, yeah, I would agree with you. It's probably at least 1 because, we can assume. Well, I mean, look, in theory, you can be a member without declaring any interest, right? But let's imagine, I mean, we're making that assumption that whenever you're registering, that field that asks about your interest, is mandatory. So yeah, let's say it's 1 or many interests, right? And one interest can be related to how many members? Minimum, maybe 0, I don't know, 1, and maximum many, right? Because many people can be interested, let's say, in big data, right? So it's a many-to-many relationship, right? So in that case, we need to resolve it by introducing an associative entity in between. Last time we spent the whole class talking about associative entities, right? But once again, I will say this is like a transaction journal. Whenever those two entities come into transaction, member declares his or her interest, right? Then we add a row here, okay? So we'll call it member interest. So for example, let's say somebody comes in and says, hello, my name is Michael. I'm interested in big data, chemistry, and biology. So we'll add 3 rows, 3 entries to this particular entity, right? And in that case, if we do it like this, then one member interest, think about one row entry here in this associative entity, will be related to how many interests? Minimum. Minimum 1, because you cannot have like a blank declaration, right? What is the maximum? I think it's also 1, right? Because it's 1 interest per entry, right? So we'll have 1 on that side, and here we'll have what? 1 interest can be declared how many times at the minimum? I think we agreed 0, right? It could be that nobody has declared that interest yet, right? It's a new subject, right? And maximum many, somebody, let's say big data or chemistry has been declared as an interest many times. So we have 1 on this side and 0 many on that side, right? So if you declare member interest, it's for exactly 1 interest. However, 1 interest, maybe interest is a bad name, right? Because interest is sounds like a counting term. But let's keep it this way, because we don't want to rephrase everything. I mean, what would be like a better name instead of calling it interest?
Genre.
Subject, maybe? Genre I think is a good one, right? Genre. So it's spelled like this, right? Okay. Okay. Also, I mean, I think the cardinality is the same on this side. So if one declaration is associated with exactly 1 member, so you have 1 on this side, right? And 1 member can declare interest 0 many times, but I think we agree it's like one or many times, meaning we cannot allow somebody to have no interest, right? So it's this one, all right? So it's 1 or many on this side and 1 on this side, okay? So we resolve this many-to-many relationship by introducing an associative entity, okay? So once again, we don't worry about attributes now. We're just creating a sketch, right? We're creating a rough draft of our final ERD model, okay? Okay, so this is first step, context data model. Now, second model says key-based data model. So again, you don't worry about all attributes. Just try to keep things simple at first. You're trying to figure out the keys, right? Keys meaning primary keys and foreign keys. By the way, when you go back to the case, they give you a lot of details that kind of tell you what specific attributes they want to have, right? For example, they specifically tell you that many members can have the same name, which kind of suggests that you need to use some kind of ID instead of identifying members by their name, right? So let me add just a key, member ID, and please don't forget to mark your primary and foreign keys. Okay, like this. Can you see it on the screen, by the way? Can you see the font? Yeah. Okay. Let me zoom in a little bit when I concentrate on certain entities. Okay. Now, member interest ID will be our primary key here. Just some kind of identifier where every declaration of an interest is assigned a particular ID number, okay? Now, don't forget, this is an associative entity, and because of that, this key will be of what type? Starts with C. Compound, right? Compound or complex. Compound means consisting of several parts, right? So one part will be what? What will be the first part? The first part will be the primary key of this entity, right? Member ID. By the way, technically speaking, it's a foreign key because it's a primary key that is inserted into another entity. So it kind of fits this definition. But you don't have to mark it as a foreign key. I've seen like people do it. They put it like as a foreign key here. That's okay, but you don't have to do it. It's clear to me that this comes from somewhere else, right? Because it has this dot notation, right? And then, I mean, dot notation means it belongs to this primary key, and then by the name, you know that it comes from here. It's the same attribute. Because you cannot have attributes with identical names in your ERD diagram. So the first part is member ID. What's the second part of this compound primary key? It should be this primary key. So we'll put genre ID, right, as a primary key. So genre ID will be added as the second part of this primary key, right? What about here? What kind of primary key will we use? How would you call it? To keep track of books. Actually, they discussed the subject. They're saying, well, there can be many books with the same title, right?
Your reference number?
Yeah, some kind of ID number, right? So let's put like, I don't know, reference ID. Now, we're getting into the library science, which is a big field. You can get a master's degree in library science, for example. I know that for sure, because a friend of mine got it. Figure out like the exact nature of those attributes requires some knowledge of the subject matter, meaning library science, right?
Could you just use like ISBN?
Actually, I was about to get that's what I'm trying to get into that. I think based on my understanding of library science, because I'm not like a professional librarian, I think it's a bad idea to have ISBN. The reason it's bad to have ISBN as your primary key, because based on my understanding, ISBN is assigned to every edition of a book, right? So for example, all of you have our textbook and it has the same ISBN. But you understand that technically speaking, those are different books, different instances, right? Most libraries, they will carry several copies of the same popular title, right? So in that case, you cannot use ISBN because you will have 3 books having the same ISBN. That's how I understand it, right? I know that nowadays, again, we're entering the field of library science. They use something called DOI. It's called Digital Object Identifier, right? Now, this is something that is unique for every resource. In other words, they're using it for electronic resources, as far as I know. So every article that you publish, like every ebook, will have like a unique identifier. So maybe there's something better to use, but I just don't know because that requires knowledge of the subject matter. Okay, and that's why if you're working as a system analyst with the library, you'll have no choice but to get yourself educated about those matters of library science, right? So to keep it simple, let's call it reference ID, or let's make it even simpler, book ID, right? To make sure we know that it comes from this entity. Okay. So once again, now we have 4 entities. Member entity with member ID as its primary key. Then we have compound primary key here in this associative entity. And then genre ID and book ID. Now there's something that is missing. We haven't figured out all of the keys, right? And I'm hinting you, something is missing here, in the relationship between these 2 entities. So what kind of key is missing? So what is missing here? Go ahead.
Maybe a foreign key from the genre to the book.
Exactly, right? We're missing foreign keys. Remember we had this discussion. Okay, you know that those 2 entities are related. How do you implement this relationship, right? And a short answer is that you implement this relationship by inserting primary keys from a primary key from one entity into another, right? And once you do that, once primary key from one entity is inserted into another entity, it becomes a foreign key, right? Now, what I would like to ask you about is, which primary key do we take, genre ID or book ID? Which one do we insert?
You would insert book into genre.
Well, I'm sorry, this is wrong. This is. Thanks for trying. I don't want people to be upset if they get. That's a good idea, but it's a wrong one. Because we have only 2 options. If it's not this one, then it's the other one, right? Guys, remember the rule. Remember last time I repeated this rule 3 times. One time after another and then after another. The rule is this: the child entity is always on the many side. The child entity is always on the many side. Once you know which entity is a child entity, you take primary key from the parent entity and insert it into the child, right? So that's the rule. And remember, I give you an analogy of you and your father. Well, actually, it may not be applicable to everybody, but I told you in my culture, and I know in many other cultures, your middle name is your father's first name, right? Because here in the US, it doesn't have to be your father's first name, right? It can be pretty much anything, right? I know. I think it's the same thing in Arabic. In Arabic countries where people's name is basically their first name, then their middle name is like their father's first name, then their grandfather's first name, right? I think in Spain, in Spanish-speaking countries, they kind of do the same thing, but it's also they insert both father and mother name, right? Something like this. So, anyways, I was trying to illustrate you this by analogy. If you think about your name, and let's say you come from a culture where your middle name is your father's first name, right? You understand that he's your parent, and it is his key, his identifier that is being inserted into your entity, and not the opposite, right? I mean, your father will not have middle name that is your first name. Just doesn't make sense, right? So the key always comes from the parent entity, not from the child entity. So in that case, we need to take this key and insert it here. Look, guys, I will just repeat this point once again. I mean, those can be treated as foreign keys as well because they come from different entities. But you don't have to do it because it's clear enough that those are components of the primary key, this one, right? Those are two parts of this primary key, and they come from those two different entities, okay? So we're done with this part, key-based data model, okay? So it says eliminate non-specific relationships, meaning many-to-many relationships, add associative entities, we did that. Include primary and alternate keys. We don't want to create any alternate keys just to keep things simple, just one primary key. And then precise cardinality. So we figured that out, right? We didn't do any cardinalities, but maybe like by creating keys, you can kind of get a better sense what kind of cardinality you have, right? Maybe you didn't get it right on the first attempt, but after thinking in terms of primary keys, you will get a better idea of the cardinality, right? So we're done with step 3. So this is like another slide that says, the key-based data model will look something like this, only keys, primary and foreign keys. We have something similar to this here, okay? Okay, so what is step number 3? Here. Full attributed data model, okay? So basically it means specify all the attributes in your ERD diagram, okay? I do it really quick, and maybe my attributes will not be 100% correct. Again, you need to read the case to really figure out what kind of attributes are important for them, right? I'll do it really quick, just out of the top of my head, right? So maybe there's a better way of adding attributes. I may be wrong, but from what I remember, the assignment tells you that you need to have at least 5 attributes per entity, right? So I know that it's not realistic because in real life you can have 5, you can have 3, you can have 500. I don't know how many, but I just want people to brainstorm about attributes, or at least put some attributes in each entity, right? As opposed to just leaving it like this. Okay, so let's do it really quick. So we have member name. Again, you can specify it as a compound attribute, like member last name. And then member last name, first name, right? Well, I should have put it first, so I'll keep it like that. What else?
Address.
Yeah, member address. I'll keep it like this. You can break it down into components like street, street name, house number, apartment number, zip code, city, and all those things. Anything else?
Telephone.
Yeah, member, phone. Well, I'll leave it like that. So we already have 5, right? You can add additional ones if you want to. So member interest ID, which is that associative entity. So let's say we already have at least 1 or maybe 2, depending on how you count it. So let's just think about things that may be worthwhile to store. I'll do it really quick myself. We'll come back to those attributes later. So I'll put member interest date, and then I'll put member name so that we know who declared a particular interest. Then we'll put, let's say, genre name, that future attribute from this entity. By the way, here I will add like a couple of things just for illustrative purposes. Something came to my mind. I will add member DOB, which is date of birth, and I will add, let's say, member age. Okay. I'll do this. I'm not thinking about whether those are good attributes or not. I'm just going quickly through this. For genre, I will add what? Genre name. What else? So genre name could be, let's say, big data. Let's say genre description. It's like a memo type of field where you have like a one paragraph description what the subject is all about. Let's say I'm adding genre, let's say classification, whatever that is. So let's say we have classification, meaning is it for kids, adults, or genre, let's call it genre age. So let's say we classify each genre as being like kids, young adults, something like that, right? Look, I already came up with 4, so help me out with the 5th one. What do you think we can add to this entity?
Fact or fiction? Fact or fiction?
Okay, good point.
Fiction or non-fiction?
Okay,
Fiction.
so I'll just put like fiction, yes or no. It's like a Boolean attribute, right? I think, sometimes they would name it like this, is fiction. So it's like a question, is fiction, yes or no, Boolean attribute. Okay, friends, thank you. We have already 5. Let's do quickly the same thing for book. So we have book ID, genre is a foreign key. Typically, foreign key is the last attribute. So we'll add book title. Look, by the way, this is my naming convention. Always, when you name attributes, the first part of the name is always the name of the entity.
Would you do like a subtitle for like a series of books?
Okay, so let's add book subtitle. Then book ISBN 10. I think there's a 10-digit version. Then
Also like part of a series or something. Part of a set.
Like author.
I like how Lord of the
maybe edition or
kind of like how Lord of the Rings or several that make up Lord of the Rings.
okay, let's call it like part, right? Part number, book part, something like that. Or book sequel. I don't know what is a good term. Okay, let's call it book series number. Okay. And then I'll just add really quick, and we don't want to like spend too much time here. I'll add like book author, let's say. Okay. Okay, friends. So let's assume we're done. Let's say the requirement is that we need to have at least 5 attributes per entity. So in a way, we met our requirement. It requires, meaning we constructed an ERD model. Okay. Now, the model is there, but the question becomes, is this model good or not? Okay, Hannah, what do you think? Is this a good model? Is there something that is missing? I mean, just by looking at entities and attributes. I mean, do you see any flaws in this model? I mean, other things being equal, meaning like we're not talking about adding additional attributes or anything like that. Do you see any flaws, any mistakes? No? Okay. So this is our next step, by the way, determining whether the model is good. And this step is called normalization. Okay. By the way, guys, the same thing is explained in your textbook. There's a tutorial A that I recommend that you read, especially for the for the purposes of your first exam. It kind of explains the same thing, but in a less scientific, like informal way, right? So in other words, they give you like I think 6 characteristics of a good ERD model. Okay. We'll try to explain it in a scientific way so that you understand like the theory behind it, because I think once you understand the theory, you become a real engineer, meaning you can really change things and design things better. If you don't understand the theory, then you're more like of a user of something. You're not like an engineer. You cannot design those things on your own, right? Just like if you drive a car, you know how to drive it. You're just like a driver. But if you really understand how the engine works, right, you can repair it, and it will also help with your driving because you'll have a better understanding like why your car responds a certain way, right? So we'll try to do it in a more complicated scientific way, and I hope you don't see it as a more complicated way. You see it like as a more, I guess, as a deeper way of understanding like this idea of creating a good data model. Okay. So once again, it's called data normalization. Okay. Now let me give you some background information if you don't mind. Now, what are some general principles when it comes to creating a good data model? Number 1, a good data model is simple. Okay? Simple, I mean, I don't know how to describe it. It means simple, meaning it's not complicated. It doesn't have too many things. It doesn't have too many attributes, too many entities, right? Have you heard there's a saying that says, like, simplicity is a sign of genius, something like that? Have you heard this saying? No? Well, I mean, I totally agree with the saying. It doesn't take much intellectual power to explain something in a very confusing way, right? In fact, I think, there's a famous philosopher of science that I like. His name is Imre Lakatos. He said something like this: scientists often hide misery of their thought behind complicated sentences, right? So, in my opinion, it doesn't take much effort and much brain power to explain something in a very fuzzy and complicated way. It does take a lot of profound understanding, a lot of intelligence to explain complicated things in a very simple way, right? So simplicity is good, right? Simplicity is good, it kind of pays off. It's hard to do things in a simple way. I don't know whether you met people like that. I'm deviating from the subject a little bit to the business context. There are a lot of people out there, and I've met a lot of them, who think that doing things in a complicated way is actually better. In fact, they take pride. They take pride in introducing complicated processes and procedures, right? In reality, it's the opposite. Doing things in a very simple, fast, efficient way takes a lot of effort, takes a lot of intelligence and thinking, right? So a good data model is simple. I don't want to talk about those specific dimensions because they won't make sense until we talk about normal forms, right? Another important principle, a good data model is essentially non-redundant. By the way, redundancy means what? What do you think redundancy means in the context of ERD modeling or in general?
Same information repeated.
Yeah, redundant means like you don't have any repetition, unnecessary repetition, right? Now, in my job, which is lecturing, I do redundancy. I repeat things many times over and over again because that's related to learning. Like in order for something to become a part of the brain circuitry, it has to be repeated or practiced many times, right? But in general, redundancy is not good, okay? You know, when I talk about redundancy, one person that always comes to my mind is my older brother. Now, he's my hero when it comes to living a non-redundant life, right? One interesting thing about him is like he doesn't own too many things. Like if you look at his apartment, if you look what he has, you know, very basic furniture, nothing extra. He freaks out people when he travels because sometimes he travels international with a small suitcase. I don't know how he does it, but everything that he needs for one week trip or 2 week trip abroad fits into one suitcase, right? And then I've noticed like he owns like only one pair of sneakers, like only 1 or 2 t-shirts. You know, whatever he needs is like very minimal numbers, right? And I admire him because it's some kind of life philosophy because unlike me, he always knows what he has, what he doesn't have, where his things are. He doesn't spend much time cleaning. It takes him 5 minutes to clean everything because he doesn't have redundant stuff lying around, right? But if you live a complicated life, if you have, 50 t-shirts, 20 different pairs of shoes, you have 2 cars, you have 5 bedrooms, then you need to have a lot of things to worry about, right? And life becomes a bit complicated when you own so many things. Do you agree with that or not? Because you start thinking about doing laundry, about throwing something out, you know. So redundancy is bad. You know, if your life is full of redundancies, it becomes complicated to manage, right? So the same thing applies to your ERD model. Redundancy means don't include things that you don't need because you will clutter, you'll create a mess in your ERD model, right? Have you seen those people like who sometimes, you know, I've seen like some people like let's say we're talking about a teenager, they live in a room and they just keep buying those things like different posters, different toys, and then after a while their room is just completely trashed. You cannot even step inside. There are like all the stuff lying around, right? Now imagine, and those are the kind of people who could never clean their room because, you know, their parents keep nagging them about cleaning room, and it's not that they're like, you know, they don't like this idea of cleaning a room. It became so complicated. They just fear, you know, they fear this whole procedure of cleaning things out, right? Because it will take so much time, you know, it will take so much effort. So don't include things that you don't need in your ERD diagrams and also in your life. Like this is my preaching message to you. And then, you know, what happens is that once you create an ERD model that is very simple and non-redundant, it's also flexible and adaptable to future needs. Right? Look, if you keep things complicated, then if something happens, then you won't be able to adapt. Okay? Again, giving you like a life analogy, think about it this way. We cannot predict future, right? I mean, we don't know like what's going to happen 20 years from now or 30 years from now, right? Life is just by definition, it's unpredictable. Okay? However, you can, you know, and this is something that Nassim Taleb writes about, one of my favorite thinkers about probability and uncertainty. He says, look, you cannot predict future. However, you can get ready for future, no matter what future holds for you, by doing some things on your side, right? Now, one thing you can do to get yourself ready for future, keep your life simple, right? If your life is simple, then you can meet any kind of future. If your life is very complicated, and by that I mean, let's say you have a lot of loans, and when you have a lot of loans, your life is complicated because you're gambling on certain things in the future, that you will be healthy, that you'll have a good job, right? If you have too many commitments, if you have too many assets to maintain, then you're making your life complicated and you're making yourself vulnerable to the future, right? You know, I always kept wondering, like when I lived in Houston, for example, or in the United Arab Emirates, it's extremely hot and humid in those climates, right? And naturally, everybody has AC. I mean, people just, you know, they sit inside the room under AC, right? Now, the interesting thing is that their ancestors, I mean, in Houston, I don't know, 100 years ago, they didn't have any ACs, right? In fact, I asked some old people in Houston, like, what did they do during this kind of weather without ACs? And they told me, like, one thing they would do, they would put, like, a blanket into water, right? And then they would wrap themselves into this blanket, and it keeps them cool. You know, this wet, damp blanket keeps them cool for a few hours. Then they wake up again in the middle of the night. They put, you know, this blanket again into the water. They wrap themselves and they sleep, right? So basically, what I'm saying is that nowadays life is so complicated. Everybody has AC. I wonder what's going to happen if there's some kind of natural disaster where there's an outage and people don't have access to AC for a few days, right? I know in the UAE, and I think there's the same thing in Houston. Once they have any kind of power outage due to hurricane, a lot of people die, unfortunately, right? Especially older people who have health problems because they're not used to living without AC, right? So sometimes just living without AC for a few days is enough to kill somebody, right? Now think about it, right? In a way, when you make your life, you know, advanced, technologically advanced, in a way it's a good thing, but you're also making yourself vulnerable to the future, right? With ERD modeling, if you keep things simple and non-redundant, you'll be ready for any kind of future. You can easily fix and modify things without getting lost in the complexity of your ERD model, okay? So this is our conceptual introduction. Now, the specific technique that people use to make sure that their data model is good, the specific data analysis technique that people use is called normalization, okay? So normalization basically means you normalize your data in your ERD model by going through certain normal forms, okay? Let me give you like a few background ideas here, or some background information. So today we will talk about 3 normal forms. There are more than 3 normal forms out there, okay? And by the way, each of those normal forms is like a mathematical slash Boolean theorem. You know, it has like a mathematical proof behind it, right? But we're gonna talk about the practical side of those theorems, okay? So, so basically, this is how normalization works. In order to create a good model, right? In order to create a good model, you need to put your model into the first, then second, and then third normal form. Okay? So in other words, a good data model meets those 3 normal form requirements. Okay? There is also like a logical relationship between those forms. You cannot say that your ERD model is in the second normal form unless you also put it in the first normal form. Right? So saying that your model is in the third normal form also assumes that you met second normal form and first normal form requirements. Does it make sense? So kind of one assumes the other one, right? So for example, if you say that you have a PhD degree, right? Let's say you declare you have a doctoral degree, it's kind of assumed that you also have a master's and bachelor's degree, right? So the same thing here. If you're saying that your model is in the third normal form, you know, you can only say that if it's also in the second and first normal form, okay? Okay, so let's go through those normal forms. I think the first normal form is relatively easy to understand. Look, it says, let me phrase it this way. If you're claiming that a particular entity in your diagram is in the first normal form, if you're claiming that, then you need to make sure that this entity has no more than one value for a single instance of that entity, right? Again, we're talking about attribute cells. So if you're saying that this entity is in the first normal form, then you're claiming that this entity does not have attributes that can possibly have more than one value for a single instance. Okay? Let me give you like one example that comes actually from that other pre-recorded demonstration. So let's say you have a student entity, right? An entity called student, and there is an attribute in that entity called major, meaning student major. Okay? Now, consistent with this definition, do you think it's possible to have one student, meaning one specific instance, one student, that has more than one value for that major attribute? In other words, what I'm asking, do you think one student can have more than one major? He can, right? He can have more than one major. This means first normal form is violated. Again, if you imagine your entity as a table, you understand why, right? You cannot put 2 values into one cell. That will contradict this tidy data principle, right? So think about it. You have table for a student, and there's a column called major. You cannot put for one student, meaning for one row, 2 majors into one cell, right? So that violates first normal form. It means there is an attribute that can possibly have 2 values for one single instance. Okay? So that's a violation. So you need to resolve it. How do you resolve it? I'll show you in a second. But you resolve it. If you have an attribute that violates first normal form, it means you need to remove this attribute out, and you need to create a separate entity for that attribute, because having more than one value in that attribute suggests that you need to have a separate table keeping track of those things. Okay. So this is first normal form. Now let's go back to our data model. And I'm going to give you a hint. One of the attributes in this book entity violates first normal form. So think about it for a minute and tell me which attribute violates first normal form. Which attribute can have more than one value for a single instance of that entity? Go. Yeah, I think several people saw the author, right? Some books are written by several people, right? Which kind of makes it interesting. How do you write a book together? Okay. There was like one of my favorite two authors who wrote all the books together. They were saying, well, how do you write those books? I said, well, one person is writing, the other person is just walking around asking editors for money and buying food and groceries for the second writer, right? But you know that some books are written by more than one author, right? So you cannot have a record like a row, and then you have a column that's called book author, and you want to enter like 3 authors there. Okay, so that's something that violates first normal form. So in that case, we need to take book author out, and we need to create a separate entity, right? By the way, things will get a bit complicated, I think, because it will be a many-to-many relationship. So let's say you have an entity called author, and then we have author ID as a primary key, and then author name, and then author date of birth. So I'll just enter 3 attributes, okay? So one book can be associated at the minimum with how many authors? Yeah, minimum 1. You cannot have an anonymous book, right? I haven't seen books by nobody. Well, actually, sometimes they do have like some kind of manual online that says anonymous, right? So let's say minimum 1, maximum many, right? And one author can be associated with how many books? Minimum. Minimum 1, because by definition, if you don't have any books, you're not an author, right? And maximum many, right? There's a writer, I forgot her name, she's a lady writer, she wrote like detective novels, and she wrote like 180 books in her lifetime, right? And everybody's wondering, how do you write like in 10 years, how do you write 180 books? So some people are saying she has like 3 little dogs in her house, and she puts them on the keyboard, and they're just jumping on the keyboard and typing like all those books. Because they're saying like her books that do not make any sense. They're just too cheaply made. She doesn't put much thought. But I think in reality what happens is that she hires like people to write, to kind of shadow write things for her, right? And then she puts her brand name because people know her name and they're buying her books, right? So anyways, it's possible for an author to have many books, up to one or 200, right? So it's a many-to-many relationship, right? So let's resolve it right away. So we'll have an associative entity called book author or book authorship. And I hope you see like what kind of info is entered into this entity. Whenever one author is registered as an author of a particular book, we'll make a row entry there. So it will have a compound primary key. That will have several parts. It will have, what will be the first part? It's book ID, right? And the second part is what? So it will be primary key from which entity? Well, the book ID is already here, right? So we need to figure out what will be the second part. So this entity links books to what entity? To author, right? So we need to have author ID right here. Okay? And then, I don't know, we can enter other attributes, but we'll keep it like that. So in that case, one book authorship is associated with exactly one book, right? And one book can have many authorships. It cannot have 0, so it's like one or many and one here. So one book authorship is for exactly one book, but one book can be authored by different people at least once, but at the maximum many times, right? And one author at the minimum, one book authorship is related to exactly one author because one entry for each author, right? So it's one on this side. And one author can write minimum 1, maximum many books. So it's the same kind of cardinality here, right? Okay, friends, you see what happened? We found an attribute here that violates first normal form, and we resolved the situation. Of course, it led to certain complications, right? Because we created this entity called author, and then we had to create another associated entity, right? But we fixed the first normal form problem. So they're saying this model is better than the previous one, okay? Now, just take a look at those two attributes, or three attributes, and tell me whether you see any first normal form violations there. I don't see any, but maybe I'm wrong. Maybe you can find some violations here. Just take a look at it for a second and tell me whether you see any first normal form violations.
In the number you can have phone.
Okay, so maybe it just means it's not precise. So maybe we need to have, perhaps you can have two separate attributes saying like home phone, office phone, cell phone, right? Or perhaps you can create a separate entities like phones, keeping track of people's contact details, right? Maybe in some situations, you know, like, by the way, it doesn't happen in the United States, but in some other countries, including in Ukraine and the UAE, something is happening that drives me insane. You know, people keep switching their cell phone numbers, right? And the reason they do it because like all those promotions, like, you know, there's one operator that says, well, if you sign up for our phone number, you will have like free, you know, free conversations for the next 3 months, right? I mean, I understand people are doing, but it drives me. I mean, I know people. I have no idea like what their phone number is. They keep changing their phone number every 2 months, and then they keep saying, "Well, I sent you this message, or I called you, you didn't pick up." I said, "Look, I don't know who you are. Like, you know, you keep calling me from different numbers every month. I'm starting suspicious. I'm already suspicious about you and what you do, right? Because you keep changing your phone every month, right? So to me, it's already maybe this person is hiding from somebody or something like that, right?" So maybe in some situations you do want to keep track of people's phone number, right? I'm sure like some applications here in the United States, they also keep track. So if you move, they still keep track of your phones, right? Let's say for credit verification purposes, okay? So maybe, yeah, maybe it makes sense to create a separate entity called phone. So you're right. Anything else? Well, I don't see anything right here, right now. So if you find something later, you know, you can bring it up. Okay. So that's first normal form. Okay. Now, second form is a bit. I think in a way it's a bit hard to formulate. But I think from a you know, you can have like a very you can quickly develop an intuitive feel for it. Okay. Without understanding like this precise formulation of this theorem. Okay. So. So look, that's what second normal form is all about. If you're saying that a particular entity is in the second normal form, then it means that you don't have non-primary key attributes, meaning attributes that are not a primary key. They are dependent on the partial key. So let me rephrase it in a different way, from reversing this statement. It basically means if you're saying that your entity is in the second normal form, all of your attributes, all of your non-primary key attributes need to depend on the full primary key and not a portion of the primary key. Okay? So once again, attributes need to depend on the full primary key, not a portion of it. Okay? I know it sounds like a bit kind of dry and theoretical, but this is how it looks like in practice. So look. We have this entity among, we have one associative entity here, right? Now, this associative entity has a compound primary key, right? Which means that this key has several parts. So in our case, it has how many parts? 2 parts, right? I mean, member ID and genre ID. So this is like a label for those 2 parts, right? So it has 2 parts. Now, consistent with the definition of the second normal form, you want to make sure that all other attributes, meaning all attributes that are not the primary key, that are not the part of the primary key, depend on the full primary key, meaning both member ID and genre ID, and not on one portion, such as member ID or genre ID. Okay? One way to rephrase that, and I think one intuitive way for explaining it is this. Just think about it this way. If you need to find out value of a specific row for this attribute, let's say member name, do you need to have both member ID and genre ID, or you just need to have one of those keys? Okay. I know it's a silly example. It's a silly example because it doesn't happen well, sometimes it happens in real life. It happens with my students. Something along these lines. I get an email, right? Sometimes from an email from an email alias that says butterfly12345@hotmail.com, right? And the email says, "Hello, this is me. Can you please tell me when the homework is due?" Something like that, right? So you see, I cannot answer this question. I don't know who that person is, right? Which class this person is from, which homework number 1, number 2, which section, right? So it's like an empty question. So imagine a similar situation. You work as a librarian. Look, guys, I'm talking about this attribute. We're analyzing this attribute, member name, right? So imagine this. You work as a librarian, right? And you're sitting behind desk. And I come to you as a customer, and I'm asking you this question. What is his name? This is my question, literally. What is his name? Okay? Can you answer this question? It doesn't make sense, right? I mean, the first thing that comes to your mind, who are you talking about? Give me some additional information. So let's say I give you additional information. I give you ID. So I'm saying, what is the name of the person with the ID 1, 2, 3, 4, 5? Okay? What is the name of the person with the ID 1, 2, 3, 4, 5? Can you answer this question now? You can, right? Because you'll use this ID, and you'll look up based on ID record here, and you'll give me the name. Do I need to provide you genre ID or not? No, right? So I don't need to ask you, like, what is the name of the person with ID 1, 2, 3, 4, 5 who also declared, history as his genre? I don't have to do that. All I need to do, I need to give you member ID. Okay? This means member name depends on the partial primary key, meaning on member ID, and not on the full primary key. Does it make sense? Okay? But even more intuitive way, some people have a good intuitive feel for it. I mean, if you think about it, this attribute, member name, just doesn't belong here. Member name attribute belongs where? To the member entity, right? And by the way, when you put it into the member entity, this is how you result. You remove it from this entity where it doesn't depend on the full primary key, and you put it inside the entity where this attribute will depend on the full key. So if you put it here, member name, it depends on this full primary key, right? So you need to have member ID to find somebody's name, specific name, okay? So this is what second form is all about. You need to put attributes where they belong to. By the way, the same thing applies to genre, right? If I ask you a question, what is the name of the genre, right? You cannot answer this question. But if I say, what is the name of the genre with ID 1, 2, 3, you can answer that question, right? I don't need to give you member ID to find out value of this. Which means we need to delete this attribute and put it where? So we remove it from here and put it where? Into the genre, where it will depend on the full primary key. And it's already in here, right? You have genre name. Now, you see what you're doing? You're simplifying your model and making it non-redundant by following that second normal form. Okay? Look, guys, last third normal form. I think it's the easiest to understand. Okay? The third normal form says this. If you're saying that your entity is in the third normal form, you should not have non-primary key attributes that are dependent on other non-primary key attributes. In other words, you shouldn't have any mathematical or logical dependencies among your attributes. Okay? So once again, you shouldn't have any mathematical or logical dependencies among your attributes, non-primary key attributes. The kind of dependencies I'm talking about where one can be calculated from another one, right? Let me give you like a very simple real life example. Let's have this. Look, if you tell me that you own a car, well, actually, wait a second. Well, I'll tell you my example, but then tell me whether this example is right or wrong based on your knowledge of Kentucky legislature, right? If you tell me that you own a car, right? From this attribute, car ownership, yes or no, I deduct that you have a Kentucky driver's license. Okay? Because I remember when I came here, they basically told me if I don't have a Kentucky driver's license, I can rent a car, but I cannot own a car. To own a car, to have a car registered to your name, you need to have Kentucky driver's license. Is it correct? No?
I don't.
I think valid driver's license, because I have Tennessee, I can come up here and buy a car.
Okay, let's call it not Kentucky, but U.S. license.
Yes.
Yeah, okay.
I have an international one. I registered a car.
So you can have a car with non-U.S. license? Okay, then that's a bad example.
You can't drive it off the lot. They won't let you drive it off the lot. You would have to have it delivered to your home, or you.
Okay, so you can own it, right? Okay.
You can't drive it off the lot.
Okay, let's use my old boring example. If you're telling me you have a PhD degree, right, then I also assume that you have a bachelor's degree, right? Because it takes at the minimum doctoral programs require you to have a bachelor's degree to enter. Although there are some exceptions from that. I know there are some people, very famous scientists, who don't have a bachelor's degree and they have a PhD degree. There was one guy. He works at MIT. He's a mathematician. He's like one of those crazy geniuses. What happened was he was completing his bachelor's degree. He was already accepted into MIT to their PhD program because he was a brilliant mathematician. And then he had some kind of fit of anger during his bachelor thesis defense where he got really upset with his advisors. And he just flipped everybody off, said, hell with you, I'm not defending my bachelor thesis. But he was so good, he was still accepted to the doctoral program. But formally speaking, he never got his bachelor's, right? But formally speaking, you need to have bachelor's if you have a PhD degree, right? So for most people, if you tell me that you have a doctoral degree, I can deduct, right, logically, that you have a bachelor's degree, okay? So that's a logical dependency, okay? Now, the dependency can be of mathematical nature, meaning like you can simply calculate one from another, okay? So for example, if you tell me that your monthly income is $1,000, I can calculate your yearly income. I will multiply 1,000 by 12, right? Something like that. Okay? So those are the kind of dependencies that we are looking for. So in other words, you shouldn't have any dependencies of that nature in your ERD model. Why is that? Think about it. Like, why do you think you shouldn't have any dependencies of that sort in your ERD model? It's something related to simplicity and redundancy again. Let me give you like a specific. Let me ask you a specific question. Why do you think you don't want to store in one entity both somebody's monthly income and annual income? How does it make things complicated and redundant?
You have like two incomes. It's kind of like, I don't know. I guess it's kind of redundant because like you can kind of.
It's redundant, right?
Figure out what the monthly income is from the yearly, or like.
Yeah, it's redundant, right? Think about it. If you have monthly income, let's say you want to find out somebody's yearly income, you can write a script, right? Then just retrieves from the database monthly income and multiplies by 12, right? Or similarly, if you have annual income, you can calculate monthly income by dividing annual income by 12, right? So don't do it. If you don't need it, then don't store it. If somebody needs this data, they will write a script that will do all those calculations, right? So that's the principle. Don't include things that you can calculate if you want to, right? Now here, in this model, I'm going to give you a hint. In this entity, there's a violation of the third normal form. I'm talking about member entity. Yeah, age, right? You can always calculate somebody's age from date of birth, right? In fact, it's kind of silly thing to have an attribute called age because what, you're going to be updating it every year, right? Doesn't make sense. Just store date of birth, and if you want to calculate somebody's age or average age in the library, then you can do all those things with the script, let's say, right? You don't have to store this data as an attribute, okay? So this is third normal form. Let's see. Do you see any other violations of the third normal form?
Wouldn't
Hmm?
X be N?
So you're saying one can be deducted from another one? Well, I'm not sure. You may be right. I'm just saying I'm not sure about that.
X numbers from N.
I don't know. You may be right. I'm not sure. It could be you're right that you can deduct ISBN 10 from ISBN 13. You may be right. I don't know enough about those codes to say yes or no. But it's a good observation. Well, I don't see any violations of the third normal form either. Okay. So look, guys, that's what you need to do. You need to, once you create an ERD model for your assignment 3. Okay. Once you create a model for that, you need to normalize it. You need to think about those normal forms. Okay. What I will do when I grade your ERD model, if I see like too many violations of the first normal form, the second normal form, then I will deduct like using that rubric like a point. Let's say, if there's a item in the rubric that says the quality of this model is high, I would say, well, I disagree or I'm neutral or something like that, right? So make sure you think about normalization, okay? By the way, next class will be more of a lab session, so make sure when you come here on Thursday, make sure you bring your ERD model so we can work in the lab, we can discuss things, right? So it will be like more about hands-on work rather than me lecturing. Also, I would like to remind you that, okay, I'll switch it off right here.